Hello everyone. I hope my screen is visible. I am Nivedita Singh, a mobile engineer intern at Smallcase. I work on the cross-platform app and the website. And then today I'm going to share what I've learned about accessibility and its implementation in the past few months. Let's start with what are we going to discuss today. This talk will be about the basics of accessibility. Why should we even care about accessibility? Some guidelines that were set up to ensure that this is implemented well, and how Android and iOS natively allow developers to make accessible apps, and the features provided by React Native for the same. Certain problems that we as a team faced in implementing Ally for mobile apps, and then we'll have a brief discussion on Ally tool. So let's get started. What's the whole buzz about? What is Ally? So Ally is accessibility, how usable a website, app, or other digital experience is by all possible users, regardless of their ability or disability. Why should you care about making your apps accessible, apps or websites? Because over a billion people in the world are disabled and they have a higher chance of being unemployed. And every one of us is likely to be disabled in some form at some point in our lives. And some countries like the USA, Canada, they require you to make accessible websites and apps by their law. This is only for Indian government websites here, but I hope we have some improvement in this field. Also, right. So when we think about disability, I think the first thing that comes to our mind is about people who cannot see. But there are several types of disabilities. First, of course, people who are visually impaired. This disability can range from blindness, low-level vision, to color blindness. Such people use screen magnifiers and use the zoom capabilities of their screen readers. Then hearing impairments. Such people are deaf and hard of hearing. This can range from various levels of ranging from mild to profound. When we have people with mobility impairments, they can have disabilities concerning movement. So their impairment can be triggered from some physical problems or neurological disorders, because of which they cannot move their hands or feet. And then we have people with cognitive impairments, people with intellectual disabilities, or plain simple old age. They will have difficulty thinking and remembering. So let's start with an example of how inaccessible certain things in our world are and what we as developers can do to fix it. So we all know about Wordle, which is a popular word game where you have to guess a 5-letter word and then you get some clues along the way that will help you nudge you towards the right answer. Uh, some of us have played Wordle and enthusiastically share the results on our social media, like on our Twitter feeds. Like we can see it continuously. Now it gets annoying sometimes, but it gets really annoying for those people who need screen readers to go through that Twitter feed, because it's inaccessible for them and they cannot choose to look away. Their screen reader, like it gets difficult for them to stop their screen reader from reading out whatever is happening. I'm going to share play a clip of how a screen reader reads out Wordle results on Twitter. They read out a long, indecipherable list of green square, yellow square, white square, which is inaccessible and confusing. I hope you can hear.
3 green square, white large square, white large square, new line. 3 green square, white large square, white large square, new line. 3 green square, white large square, yellow square, new line. 5 green square. This is my latest Wordle. A grid of colored squares representing letters, which is 5 across and 4 down. The first and second rows both show 3 green and 2 gray squares. The green represents a letter that's in the word and in the right place. Gray represents a letter that's not in the word. The third row shows 3 green squares. one grey square and one yellow square. The yellow represents a letter that's in the word but in the wrong place. The fourth row shows 5 green squares, which means all the letters are in the right place to make up the word.
So the second half, the second half of the video was about someone who cared. They made a tool which allows us to take a screenshot of the emojis or the emojis in the worded result, and then they turned it into a descriptive alternative text of what was happening. The second part of the video was informative to everyone, even if people who don't know anything about Wordle. It provided a context, and it was generally accessible to people who require screen readers. So we might be discriminating against people who require assistive technology if our app doesn't work for us. Like, we're not doing something special if our apps are accessible. It's like deliberately using a certain color, let's say yellow, throughout our app, when we know that a certain significant portion of our users cannot see the color yellow, perceive anything about related to it, and the app will be of no use to them. Something called the social model of disability says that people are disabled by barriers of society, not by their impairments. And removing these barriers creates equality and offers disabled people independence. So someone who's on a wheelchair and requires a ramp to go to a building is not disabled because they need it. They're disabled because society, that particular building does not provide a ramp for them to access that particular place. So now that we know that we should implement, like, make our apps accessible, how do we go about it? Are there any rules that determine the right way to do things, or we can just generally cook up ways to make it work ourselves? No. So there is something called the Web Content Accessibility Guidelines, WACG, which were developed through the World Wide Web Consortium called W3C, too many acronyms, in cooperation with individuals and organizations. These guidelines provide a single shared standard for web content accessibility that meets the needs of people. They are organized under 4 principles. Major things that web and app content must be in order to be considered accessible. For each guideline, there are testable success criteria at 3 levels: A, AA, AAA, where each is progressively stricter. So let's say a website is following level A. Then that particular website won't differentiate between a positive signal and a negative signal by color alone. Like, for example, it will have some text. It won't just have a red button and a green button. Level AA would mean the text color meets contrast requirements. The ratio between the text color and the background color is of a particular value. And level AAA would mean a very dark color or a very light background, a very high contrast requirement, which is difficult to meet. So websites usually go for level AA. So let's start with the first guideline of one of the 4 guidelines, being perceivable. Small screen sizes limit the information people can view at a time when they need magnification to view it. So let's start with providing a reasonable default size for content, so that they don't have to keep on, so people using screen readers don't have to keep on zooming in and out to view content. We can position form fields below their labels so that people using screen readers don't have to scroll horizontally for accessing content. The success criterion related to zoom magnification is that text should be resizable without assistive tech up to 200%, by up to 200%. And the level AA contrast requirement is 4.5:1 or 3:1 for large scale text. The second would be operable. Your content users must be able to control UI elements through mice, keyboards, or voice commands. If they're not able to use a touch features, touch targets should be at least 9 millimeters, like buttons and icon buttons, and there should be some inactive space around. This will also help people who have fat fingers. Touchscreen gestures in apps should be as easy and predictable to carry out, and touch end events should be triggered like only when the user removes their fingers from that particular element, and there should be some on-screen indicator that remind how and when to use that particular feature. On the Gmail app, we have a feature where we can swipe right on a particular element to archive it. So if you're implementing something like this, we should give an indicator about it. And then device manipulation gestures, uh, things that are triggered by shaking the device should, like, they're fine, but they're not accessible to people who cannot like move. So for them, there should be some alternative control options, keyboard touch control options. And buttons should be placed in such a way that they're easily accessible to people who are both like left-handed or right-handed and cannot move their devices too much. Because let's say the device is attached to their wheelchair. The third guideline would be content should be understandable and it should support both orientations. So because yeah, the same reason as the last time, sometimes the devices are attached to the wheelchairs. Uh, the navigation of content should be consistent and they should appear in the same order in every screen as much as possible. And any components that have the same functionality should be identified consistently. Like they should have the same text. And we should provide some clear indication that elements are actionable. And we should provide tool tips and tutorials for custom touchscreen and device manipulation gestures. The last guideline being the content should be developed using well-adopted web standards that will work across different platforms now and in the future. One of them being we should set the virtual keyboard to the type of data entry required. If you want the user to input numbers, allow them to only input numbers using a numpad, don't confuse them. And text entry can be confusing for some people, like it can be a long drawn process. So you can shorten it up by using radio buttons, checkboxes, and automatically find out the user's date or time, etc. And support the characteristic properties of the platform, allow zoom, larger fonts, captions. And most platforms have the ability to set large font size, but they do not wrap the text, causing a lot of horizontal scrolling. Now that we have come to the next part, okay. I don't think there are any questions, so I'll just go to the next part. So, Ally for mobile apps. So, how do we implement accessibility on mobile apps using platforms like Android, iOS, and React Native? So, the intention would be to design well-defined, clear task flows with minimal navigation steps, especially for major user tasks, and then label the UI components and make sure users can navigate your screen layouts using keyboards, mice properly. So this is a brief description of how accessibility can be implemented on Android platforms natively. We start with describing each UI element by using the content description XML layout attribute. Then we can make the parent element focusable by setting screen reader focusable for true. This will ensure that when the screen reader is reading out a card with several texts, with a lot of text in it, the user doesn't have to separately focus on each element for the screen reader to read it out. All of the text will be collected together and read out by the screen reader. And then for edit text, where users can input information, the labels that we use for them can have something called label for. This will help the accessibility services. Similarly, for iOS, we have UI accessibility, which is a set of methods provided to the NS object. The NS object is a root class of most Objective-C class hierarchies, from which subclasses inherit a basic interface to the runtime system. Now, all these methods like UI accessibility container, UI accessibility action, focus, and dragging, they provide certain services like the first one provides information about views and controls in the app's UI. The second one makes subcomponents accessible as separate elements. The third one would be supporting specific actions. And the fourth would be whether an assistive app such as VoiceOver has focus on a particular element, this would return booleans. And the last one would be a pair of properties that allow you to fine tune how drag and drop is implemented. So now we're going to talk, I'm going to talk about React Native accessibility APIs. Both Android and iOS provide APIs for integrating apps with assistive technologies, like we just saw. RN has complementary APIs that let your app accommodate all users. That's your app. So we have accessibility properties like accessible. When this is true, this is similar to when we set the screen reader focusable on Android. This indicates that the view that all the children of this particular view will be clubbed together and read out in a single go by the screen reader instead of user having to individually focus on each element. We'll talk about this in a bit. Accessibility role. It communicates the purpose of the component. It can be either a button, a link. We can also have heading as the accessibility role, which will be helpful for a user when they are navigating through the different pages of the app. This will help them know what is there in a particular page so that they can quickly skip it if it's not interesting for them. We also have something called accessible label. In this particular case, we don't need a label because we have something called submit code. This is a button with a roll button, and state we'll come to that later. Something called submit code. This is the text of the particular button. Let's say this was, so we know that after we click on this particular button, it's going to submit code. But let's say it didn't have a text here, but an icon. Let's say a refresh icon. Screen reader wouldn't know what's happening here. Then we would need to add an accessible label here to tell him that this is a refresh. This refreshes everything. Right. There's something that's called accessibility state, which denotes the current state of a component. We have a disable button. We can just set it through here. Then we can have selected or expanded states. Lastly, we have something called accessibility hint. This is for situations where, let's say, clicking on a certain button is going to open the mobile browser from the app. It's not going to open a new view. We would then like to inform the user beforehand about the effects of this particular interactive element. These are the other properties available from React Native. A few of them are only specific to one platform. Like accessibility live region is a good way to make announcements specific to Android. What happens here is, let's say you have a particular view on the top of your app where you make announcements, and you're currently focused on some other view. There's a change to that particular view, you will be automatically informed about it by your screen reader. There are two types, like polite or assertive. Polite would mean your screen reader won't interrupt your whatever it's going through right now and then come back to that announcement later. Are there any? Okay, I don't think there are any questions, so I'll just continue. So let's start with some examples of ally problems that I faced, that we as a team faced while starting on a journey of making our app accessible. So a major problem is making images accessible. The screen reader can easily read out the text, but what happens when we have to convey some important information using images? Let's say you have a carousel which belongs to a particular class of elements. In this case, small case specials. Screen reader won't be able to read out the text in the image because it's a part of the image. So there should be some accessibility label assigned to this particular image to tell the screen reader what this particular browser is about. Similarly, you can have icons as buttons. Screen reader will read out functions intent crore. It won't tell you that a button exists there unless you point out that it has a role and a label. Now I will talk about this particular issue where this is an example of a small case, but we can take a general example of a particular item with a few properties like, let's say, name, label, description, minimum amount, tagger, and an icon for watch listing, for keeping a track of how it progresses. The card itself is clickable. It will lead us to a page where we get more information about this particular entity. And we also want the watch list icon to be clickable. Now, if we assign a label to the button and ask the screen reader to go through it, this is what it's going to read. This particular line, hello, blah, blah, blah. And in the end, it's going to read tap to watch list. This is wrong information because tapping on this card is going to lead us to the profile and not going to like watch list this element. Why is this happening? This is happening because of some rule that was breaking here, that we cannot have interactive controls having focusable descendants. If the card itself is interactive, its child should not be focusable. Hence, accessible is true here by default because this is a touchable element. As a result, all elements are gathered together, read out, and the icon cannot be individually focused. So the way to fix this, because we want the user to, screen reader users to watch list it, is to either set accessible false here, so that we can individually focus on the elements, or to only make the header clickable, which is the better solution here. The next problem would be, let's say the screen reader has to read this out, information in 2 columns. How the screen reader is going to read it is by saying stats, when equipped, slot head efficiency, armor 5, protection minus 30%. It's going to mess up the whole thing for someone who cannot look at the screen. They will have no clue what's going on. The problem here is with accessibility focus order in React Native. On the web, determine the flow in which things are read by looking at the DOM tree and going from top to bottom. We have no such structure on mobile apps. We don't have semantic HTML here. So iOS like natively reads elements from left to right, top to bottom, which is not appropriate for our case. So like right now, React Native has no official solution to it, but a workaround could be that we would create a wrapper that adjusts its behavior according to the native platform it's working on, and then it will group all subviews together for accessibility purposes. This was about implementations. I think like I don't think there are any questions till now, so I'll just continue. So allied tooling. What is that? We're going to talk briefly about tools that we can use to test our content as developers, whether our apps are actually accessible to users. So we can start with iOS. For simulators, we have something called the Accessibility Inspector, which we can use the crosshair icon here, this one, and then tap on the element, hover on elements to find out their accessibility properties. And we can also use VoiceOver with the simulator. VoiceOver is a screen reader for the Apple platform, and we can use it for the simulator by clicking on the control plus option command, which is called VO, since it's always used together on Mac. And then space key to click on items. If we have a physical device, we can use VoiceOver, and we have the following gestures. As a screen reader, how exactly a user would use it. Next, for Android, we have something called Accessibility Scanner. This is not for the simulator. We can also use it for the physical device. It is an app which can record workflows or take screenshots of screens and then audit them for accessibility issues like your app screens. And like it can check whether your content has labels, whether the touch target size is large enough, whether the items are clickable, or there's some contrast in the text. And then it can propose solutions. Like, for example, this is the homepage of the small case app, and we run accessibility scanner on it. We get a few suggestions. Like, let's say we have here the help icon is not accessible at all, even the account screen. This card itself, if we tap on this watch list icon, we can see more information here that this item may not have a label and the touch target size could be larger. Here are a few talkback gestures. What is talkback? It is a screen reader used for Android apps. Uh, Scanners can be used for tools, but they cannot replace a human testing your app for accessibility. Accessibility needs to be approached holistically because tools cannot convey whether your UI conveys semantic information simply and clearly. It cannot report whether it can tell you that the certain element is missing a label, but it can't tell you whether the element you've added makes any sense or not. And it cannot report on how well an app supports multiple modes of interaction, like touch or voice. So we cannot just rely on tooling. We need manual testing, like to test our apps for being accessible. Here are a few links that I had referred to while working on this topic. Thank you.